Hi and welcome to this video which is covering differentiation from first principles. So just to make a quick note that there will be no background to first principles in this video. We're just going to look at examples of how to do differentiation from first principles, so similar to the exam questions that have already appeared on the Leaving Cert higher level course. But if you would like to do a little bit more on the background of differentiation from first principles, I've linked a fantastic video from John Fletcher. It is got to do with A levels, but gives a really good background to how this formula came about. So the formula that I was talking about in the last slide was dy dx, or f dash of x, which is the derivative of y, or the derivative of the function f of x, is given as the limit as h approaches 0 of f of x plus h minus f of x all over h. And like I said, the video linked below will go through how that is derived. We're going to look at how we can use this formula to differentiate. Now, if we are asked to differentiate from first principles, we must use this formula. And the shortcut that we have is basically a way to skip this particular formula, but the question will be very, very clear if they want you to use that. So let's jump straight into our first example. So we've started off with a really nice simple differentiation. It asks differentiate f of x equals to 3x plus 8 from first principles. So they'd be very clear if they want you to use first principles. So the first thing I would ensure that you do in the question is to give the formula. So the formula is given up here on the right hand side in the yellow box. So that is the derivative of f of x is given as the limit as h approaches 0 of f of x plus h minus f of x all over h. Now what can be very useful for students is with regards the f of x given here, we can very quickly figure out, well, what would f dash of x be? What should our final answer be? Because as we work through it, if something goes wrong, and you'll know straight away if you don't get the answer. So remember our differentiating rule, bring down the power, take one away from the power, so 3x goes to 3 and plus 8 disappears or goes to 0. So this is kind of the answer that we want to get at the end of everything. If we don't get that answer, we know something has gone wrong. So what I've done is I've broken this into steps. So step 1, we're going to deal with the f of x plus h. So what I find is it can be very confusing to go straight into the full formula, especially as we get into more complicated functions to differentiate. So the first thing I would suggest to do is the top line. So f of x plus h first. So all we do in that case is everywhere there was an x in our original function, we're plugging in x plus h. So instead of 3x plus 8, so I'll grab my highlighter here, just so we can really see it. So the x here matches my x here, so x plus h is going to be plugged in everywhere there was an x. So it's just a substitution. We would have seen that before in the function section. So 3 times x plus h plus 8, multiply that out, and we get 3x plus 3h plus 8. If you could tidy anything, you would at this point, but we can't. So we'll move on to step 2. So go back to our formula. After we get f of x plus h, we're now going to do f of x plus h, and we're going to subtract f of x. So we take what we have from step 1 and we take away our original function, which is 3x plus 8. Please make sure that you use a bracket here, because often what students do is they subtract the 3x but they forget to subtract the 8. So using our brackets will remind us that both of those signs have to change. So we'll get rid of the bracket and it becomes 3x plus 3h plus 8 minus 3x minus 8. So that subtracting of f of x is applied to both terms. Now, what we would like to do at this point is to clean up. So anywhere that we can tidy, add together any terms and so on. And you'll see that we have a 3x and a minus 3x and an 8 and a minus 8. And this should always happen. When you take away your f of x, everything there, the f of x part, should cancel or should negate something that appeared in f of x plus h. So that leaves us simply with 3h, because my 3x cancels with my minus 3x, my plus 8 cancels with my minus 8, and that should always happen. So if your f of x is not disappearing in this step, something has gone wrong. So it's just something, it's a little trick to keep an eye on to make sure you're on the right track. So step 3 now, we've done the top line of our fraction, we're going to put it all over h, which effectively is division by h. So we get 3h over h, which gives us 3. So the next step is we've got our fraction, we want to show the limit. So step 4 is we're going to do the limit of that whole fraction. So the limit as h goes to 0 of 3, which is simply 3. So we're going to be using a very basic rule for limits here, and that is the substitution limit. So everywhere that there is a h, we put in a 0. But as you can see, if we're doing the limit as h approaches 0 of 3, there is no h. But think about what that means. It's like, what will happen 3 as h goes to 0? Well, 3 is not affected in any way by h, so 3 won't change, it will just be 3. So that's our final answer, and we get f dash of x equal to 3, which matches what we had above from our just initial quick differentiation, and we can see, well, we're correct. So it's really important that you have step by step. So some of the main things that I find students do incorrectly. The first one is not taking away f of x properly in step 2, so make sure you use your bracket. The second thing that I see quite a lot is the limit. So students are unsure when to have the limit and when not. Limit is an operator, so once you use the operator, it disappears. So for example, I have the limit as h goes to 0 of 3. What I would do with that is anywhere there was a h, I would sub in 0, and there is no h, so I can't sub in 0, so it'll give me 3. As we work through these examples, that's a really important one to watch about using that limit properly and correctly. So let's take a second example. Differentiate f of x is equal to x squared minus 6x from first principles. Again, the first step will be to write down your formula, which I have up here in the yellow box. You do need to know that formula off by heart. So it's really important that you know it and you know it fully and correctly. Often students leave out the limit part, and just be very careful. First thing I'm always going to do is I'm going to differentiate this. So I have 2x minus 6. So I'm like, okay, that's where my answer needs to be. So I'll know if I'm right or I'm wrong as I'm working through. So step 1, I do f of x plus h. That means there's an x here, and x here. I'm now going to put in an x plus h everywhere there was an x. So I get x plus h squared minus 6x plus h. I'm going to multiply out, and I square my bracket using my shortcut, which is x squared plus 2hx plus h squared. So you square the first, twice the first by the second, plus square the last, minus 6x minus 6h. Now again, if there's anything you could do to clean up, you can at this point. This is as tidy as it can come. There is some x's that are in common, but one has a h, one doesn't. So this is as tidy as we can make it. So step 2, we're going to do our previous step, f of x plus h, and we subtract f of x. That's just, again, look at your formula. This is just the top line. I start with the top line on the left-hand side. I then extend it to the whole top line. I then extend it to the fraction and then include the limit. So what I'm going to do, I'm going to take my answer from step 1 and I'm going to take away my original function. Remember, when we take away the original function, we show that in a bracket to ensure that we get the correct signs. So we get x squared plus 2hx plus h squared minus 6x minus 6h, that was all from step 1, minus the function we started with, the original function f of x, x squared minus 6x. Let's get rid of that bracket. So we get x squared plus 2hx plus h squared minus 6x minus 6h. And then multiplying out that final bracket, it's minus x squared and a plus 6x. So we're making sure to apply that negative onto both terms. Now, at this point, we should be able to do some cleanup, and as I said in the previous example, anything that comes in from f of x should cancel or negate something that already exists. So minus x squared goes with x squared. Okay, so that should always happen, and we are left with 2hx plus h squared minus 6h. And notice that everything has a h, and that's exactly as it should be. The next step is to then put the whole fraction together. So step 3 is f of x plus h minus f of x all over h, which basically is a division of h. So we get 2hx plus h squared minus 6h over h. And effectively that's a division of h. So you have to divide each term by h. So 2hx divided by h gives me 2x. H squared divided by h just gives me h. And minus 6h divided by h will give me minus 6. So think of that fraction, that bottom line, it's a division. So we're dividing h into each term. So our final step, step 4, is to get into the limit of the fraction. So the limit is h goes to 0 of f of x plus h minus f of x over h. So we're doing the limit as h goes to 0 of what we previously had. Now, here we are looking at a limit as h goes to 0. So how we work with that limit is anywhere there's a h, we sub in a 0. So what that looks like for us is 2x plus 0 minus 6. Now this is where the limit disappears, because if I write the limit as h goes to 0, once I use that, it disappears. So now that I've subbed in my 0, I no longer have the limit written in front of it. It is simply just 2x plus 0 minus 6. And that gives me a final answer of 2x minus 6, which is exactly what we expected at the start of the question. So this is a slightly more complicated example because it has a fraction in it. Now, not that anything difficult happens, only that fractions tend to cause problems for students, and it does make the question a little bit longer to work with because obviously we have to put things over 2 lines. So space-wise, you'll actually find this a little bit longer. So just like before, the first thing I'm going to do is I'm going to write down my formula, which is up here in my yellow box. F dash of x equals the limit as h goes to 0, f of x plus h minus f of x over h. The second thing I do is then I work out f dash of x using the shortcut. So bring down the power and take 1 away from the power. So 2/3 x minus 1, and the 3 disappears. So this is what I'm looking for. And I want to make sure that my answer at the end of my first principles looks like this. So step 1, we do f of x plus h. Everywhere there's an x, we sub in x plus h. We get 1/3 x plus h squared minus x plus h plus 3. Now there's a few bits to do here. So we're going to square out the bracket first, get rid of the middle bracket, and then we'll apply the third. So squaring out the bracket, square the first x squared plus twice the first by the second plus 2hx plus h squared. Dropping that middle bracket, we have minus x minus h, so make sure you are accounting for that negative on both the x and the h, and plus 3. So next thing we have is we want to apply the third. So I'm going to put everything over 3. And we get x squared over 3 plus 2hx over 3 plus h squared over 3 minus x minus h plus 1/3. Now, you can write that x squared over 3 as 1/3 x squared. It is completely personal preference. However, I find that it's much neater to write it as a complete fraction than a fraction times like the x squared. That is my personal preference. That's the way I will always write it. I think it's much neater. I think it's less prone to error. If you look at the second term, 2hx over 3, 1/3 of 2hx is going to be too complicated to write. So in general, that's the easiest way to work. As long as you're happy to work with fractions, you'll have no issues. So the step 2 is then to take what we've got from f of x plus h and subtract f of x. So we get what we had above, minus 1/3 x squared minus x plus 3. Let's apply the negative to the bracket. And again, I'm just writing everything over 3 rather than 1/3. So we'll get x squared over 3 plus 2hx over 3 plus h squared over 3 minus x minus h plus 3. Then the negative on f of x became minus x squared over 3 plus x minus 3. So what should happen at this point is that everything we've brought in from f of x, it should cancel with something that already exists. So plus x minus x, it's gone, minus x over 3 and minus x squared over 3 plus x squared over 3. And that should only leave us with h terms. So that's what's happened. 2hx over 3 plus h squared over 3 minus h. So we move on to step 3. So step 3 is the whole fraction. So what we have in the previous step, all over h. So we're dividing it by h. Now, I've left this as quite a complicated fraction. Some people don't like these complex fractions, and that's perfect. If you want to think of it as a division by h and write it literally like a divide sign h, that is perfect. Remember what we're doing. We're dividing h into each term. So what's going to happen when we divide h into each term? This h will divide with this h. It will also then divide it one of our h's here, and it will divide with this. Now, this caused a lot of problems when students did it, because when you divide h into h, you don't get nothing. What's any number divided by itself? And it gives us 1. But it was the hardest one to see. So just be careful with that division, leaving us 1. So what we should get is 2x over 3 plus h over 3 minus 1. So that minus 1 was missing. Now, you'll know as soon as you get to the end, because your answer won't match what you've already predicted your answer should be. And that's why that prediction step can be very, very useful, especially in an exam situation. You'll know what you're missing and you'll be able to try figure out, well, where did I lose that? So the last step is we're going to do the limit of the previous fraction. So we're going to do the limit of 2x over 3 plus h over 3 minus 1. To do the limit, we sub in 0 anywhere there's a h, which becomes 2x over 3 plus 0 over 3 minus 1. Remember, once we do the substitution, the limit part disappears, and we're left simply with f dash of x is equal to 2x over 3 minus 1, which is exactly what we have above. And that's what we predicted we would have, and that's what we want. So our final example in this video is going to be looking at differentiating from first principles, a bracket to the power of 2. Now, when we want to square a bracket, if I was differentiating this normally with our shortcuts, this would be the chain rule. So I would have to bring down my power, take one away from my power on the whole bracket, and then multiply by what's in the bracket. So I'm going to work with that a little bit here. So if I have f dash of x, it will give me 2 times 2x plus 4 times the derivative of the bracket, which would be 2. So that would give me 8x plus 16. Now, that's using the chain rule to do that differentiation. You could, because it's only a squared, you could multiply it out. So square this. So you will get, sorry, change back to my color. You will get 4x squared plus 16x plus 16, and differentiate that. Again, bring down the power, take one away from your power, and you'd still get 8x plus 16. So there's two methods. Now, if it was power 3, I wouldn't bother, unless you're very good at using binomial expansion. The chain rule will be very much, well, it would be much, much quicker. So it does mean that for the actual differentiation from first principles that there is 2 ways to approach it. I'm going to do the harder way first, and then at the end I'll show you a slightly easier alternative to start the question. So the first thing I'm going to do is f of x plus h. So what I'm going to do is I'm going to take my bracket exactly as I have it, and instead of x, put in x plus h. So I get 2 times x plus h plus 4 all to be squared. Multiply out my bracket, so I get 2x plus 2h plus 4 all to be squared. And to square out my bracket, I simply write it twice, break up my bracket, and do my multiplication. And that's what I get. Now, this is really important in this step because there's so many. You should be asking yourself, oh, is there something here that is in common? Is there things I can add together? Are there like terms? So I have a plus 8x and a plus 8x. I have a plus 8h and a plus 8h. I have a plus 4hx, a plus 4hx, and nothing else can be added together. So what I get when I clean that up is 4x squared plus 8hx, that's using this and this, plus 16x, plus 16h, plus 4h squared plus 16. Okay, so a bit of cleanup. At the end, I'll show you an alternative way that we could have done step 1 in case you're looking at the video going, oh, but would it not have been easier too? Yes, there is a slightly easier way and we will look at it. But it is good to see if you want to work exactly with the fraction, how we could do that. Just sorry, before I go on to step 2, somebody else might, if you're sitting there going, well, why did you multiply out using the long method? Why did you use two brackets and then split it? Could you not have used binomial expansion? And if you thought that, just be careful. Binomial expansion, bi means two. So a binomial expansion happens when there's two things in the bracket. Because there's three pieces in my bracket here, it wouldn't be possible to use the binomial expansion or our squaring shortcut to square out the bracket. So just be careful there. So step 2, f of x plus h minus f of x, we take what we previously had and we take away our original bracket. We're going to square out the bracket and then apply the negative. Squaring that bracket, I'd already done it above, and we then apply the negative. So it's minus 4x squared minus 16x minus 16. So that front, so from here, if you look, that remains the same there, there, there. So everything to the left, nothing has changed. It's all been focusing on the right-hand side. So it's all been focusing on this part, the f of x. So this is the bit we're focusing on as we work through it. And I'm just going to rub this out just so we don't add confusion. And at this step, if you remember from our previous 3 examples, what should happen is everything from the f of x should start cancelling with something that already appears. Minus 16x plus 16x. They're gone. Minus 4x plus 4x. And that should leave us with just h's, which is exactly what happens. 8hx plus 16h plus 4h squared. So moving on to step 3, it is applying the full fraction. So putting what we had in step 2 over h, so dividing everything by h. So we get 8hx plus 16h plus 4h squared all over h. Dividing in our h, we get 8x plus 16 plus 4h. And that leads us to our final step. Step 4, the limit as h goes to 0 of that fraction. And we have the limit as h goes to 0 of 8x plus 16 plus 4h, and that gives us, so our final example in this video is going to be looking at differentiating from first principles, a bracket to the power of 2. Now, when we want to square a bracket, if I was differentiating this normally with our shortcuts, this would be the chain rule. So I would have to bring down my power, take one away from my power on the whole bracket, and then multiply by what's in the bracket. So I'm going to work with that a little bit here. So if I have f dash of x, it will give me 2 times 2x plus 4 times the derivative of the bracket, which would be 2. So that would give me 8x plus 16. Now, that's using the chain rule to do that differentiation. You could, because it's only a squared, you could multiply it out. So square this. So you will get, sorry, change back to my color. You will get 4x squared plus 16x plus 16 and differentiate that. Again, bring down the power, take one away from your power, and you'd still get 8x plus 16. So there's 2 methods. Now, if it was power 3, I wouldn't bother. Unless you're very good at using binomial expansion, the chain rule will be very much, well, it would be much, much quicker. So it does mean that for the actual differentiation from first principles that there is 2 ways to approach it. I'm going to do the harder way first, and then at the end I'll show you a slightly easier alternative to start the question. So the first thing I'm going to do is f of x plus h. So what I'm going to do is I'm going to take my bracket exactly as I have it, and instead of x, put in x plus h. So I get 2 times x plus h plus 4 all to be squared. Multiply out my bracket, so I get 2x plus 2h plus 4 all to be squared. And to square out my bracket, I simply write it twice, break up my bracket, and do my multiplication. And that's what I get. Now, this is really important in this step because there's so many. You should be asking yourself, oh, is there something here that is in common? Is there things I can add together? Are there like terms? So I have a plus 8x and a plus 8x. I have a plus 8h and a plus 8h. I have a plus 4hx, a plus 4hx, and nothing else can be added together. So what I get when I clean that up is 4x squared plus 8hx, that's using this and this, plus 16x, plus 16h, plus 4h squared plus 16. Okay, so a bit of cleanup. At the end, I'll show you an alternative way that we could have done step 1 in case you're looking at the video going, oh, but would it not have been easier too? Yes, there is a slightly easier way and we will look at it. But it is good to see if you want to work exactly with the fraction, how we could do that. Before I go on to step 2, somebody else might, if you're sitting there going, well, why did you multiply out using the long method? Why did you use 2 brackets and then split it? Could you not have used binomial expansion? And if you thought that, just be careful. Binomial expansion, bi means 2. So a binomial expansion happens when there's 2 things in the bracket. Because there's 3 pieces in my bracket here, it wouldn't be possible to use the binomial expansion or our squaring shortcut to square out the bracket. So just be careful there. So step 2, f of x plus h minus f of x, we take what we previously had and we take away our original bracket. We're going to square out the bracket and then apply the negative. Squaring that bracket, I'd already done it above, and we then apply the negative. So it's minus 4x squared minus 16x minus 16. So that front, so from here, if you look, that remains the same there, there, there. So everything to the left, nothing has changed. It's all been focusing on the right-hand side. So it's all been focusing on this part, the f of x. So this is the bit we're focusing on as we work through it. And I'm just going to rub this out just so we don't add confusion. And at this step, if you remember from our previous 3 examples, what should happen is everything from the f of x should start cancelling with something that already appears. Minus 16x plus 16x. They're gone. Minus 4x plus 4x. And that should leave us with just h's, which is exactly what happens. 8hx plus 16h plus 4h squared. So moving on to step 3, it is applying the full fraction. So putting what we had in step 2 over h, so dividing everything by h. So we get 8hx plus 16h plus 4h squared all over h. Dividing in our h, we get 8x plus 16 plus 4h. So step 4, we take the limit of our previous fraction. So we take the limit as h goes to 0 of 8x plus 16 plus 4h. That means anywhere there's a h, we're subbing in a 0. So we get 8x plus 16 plus 4 times 0. That's applying our limit. And then we get a final answer of f dash of x is equal to 8x plus 16. So I did say that I would give you an alternative method for step 1. So in step 1 here, I've looked at just subbing in directly into our original function, 2x plus 4 all to be squared. But it did lead to quite a lot of work. So the alternative would be to work instead with an already expanded version of f of x. So expanding it using our squaring, so 4x squared plus 16x plus 16, and working through there. Now, there is still some steps to work, but as you can see, step 1 is only 3 steps of working. So the algebra here, once you've squared it first, would actually make it a lot easier. Everything else will work out pretty much exactly the same. If you did this method, you might also save a little bit of time if you are working down here, because you would have already done that expansion. So you could go straight to my second line here in step 2. So you'd lose a few lines. It's a little bit easier, but it is good to see both methods and see that both methods will get us the exact same answer.